Okay, I'm going to go through the examples that are in the first part of the area segment of your booklet. First one, we're dealing with the area of a rectangle. You may remember that the formula for working out the area of a rectangle, A, will be equal to length times by width. I can write that in words if you need it. So it's area of a rectangle is equal to length multiplied by width. So in our instance here, we have to identify which is going to be our length and which is going to be our width. So I can call the long part up the top here a length of 4 centimetres. So in our case, the area will be equal to 4 multiplied by, and the width we'll call the 3 centimetres. And that will be equal to 12. The units for area are actually square centimetres or square metres, whatever the units are that we're measuring in. The way that this works is that if I was to break this up into little 1 centimetre squares, this is approximately 1 centimetre squares anyway. For the 4, we'll half it again. So each one of these should be 1 centimetre across, 1 centimetre, 1 centimetre, 1 centimetre, which makes up our total of 4 that way. Similarly, for the width, we've got 1 centimetre here, 1 centimetre here, 1 centimetre here, which is the 3 for that. If we count these all up, you'll see that there are 12. And each one of these is a square which has a 1 centimetre side length. So the area of that is 1 square centimetre, or we write it as centimetres squared, square centimetres that way. So in the example here, we'll end up with a total of 12 centimetres squared, or 12 square centimetres. So you need to remember that when we're dealing with areas, we're needing to work out how many of these individual square centimetres or square metres or whatever the units may be that we're working with. We're basically counting squares, but in many of these instances it's going to be too hard to actually count. So we're going to use some equations to work it out. The equation here is area equals length times width for a rectangle. We'll move on to triangle. So when we're looking at these triangles here, you can see that they're actually a rectangle which is cut in half in a certain way. The middle one might be a little bit harder to identify, but if you were to cut out all of those little individual triangles, you could reposition them all so that it does actually turn into a rectangle. So we can work out from this that the area of a triangle is equal to a half of the area of a rectangle and we would have said half times by length times by width, which would be satisfactory, but we normally talk about a triangle as having a base along there, and a height. So we refer to our triangle as the area is equal to the half times the base length times the height. And I'll just simplify this as half times base times height, like that. So for the first one of these triangles up the top here, so that's this one here, the area is equal to a half times the base times the height. It equals a half multiplied by, the base in this instance here is 4, times by the height in this instance is 3. So if I work this out, a half times by 4 is 2, and then 2 times 3 is 6, so that gives me a total of 6. The units for this particular question are centimetres, so the area is going to be in square centimetres. For the second example here, it all works exactly the same. So area equals a half times base times height. So it'll be a half multiplied by, the base in this instance is 5, times by a height of 2.5. Now it doesn't matter where the height occurs. The height goes up the middle here, but a rectangle is going to be parallel, so it doesn't matter where you measure the height from. It's always going to be 2.5 in this instance. And the answer to that's going to be, just got my calculator out then, and the answer is 6.25. And again, this is measured in centimetres, so we need to write square centimetres as our units. And the third one of the examples here, it's all going to work the same. Area is equal to a half times by the base times by the height. So it's going to be a half multiplied by, the base here is 3, times by a height of 2. So this will give us an answer of 3. Again, this is measured in centimetres, so the units need to be square centimetres. I'm going to write that centimetres again, squared like so. I'll do a couple more examples. These are the examples that are in the book. We need to find the area of each of these triangles here. So again, the same rule applies. So for the first one here, area equals a half multiplied by base multiplied by height, which is a half multiplied by, the base in this instance is 10, multiplied by the height of 4.5, which is going to equal half of 10 is 5, and 5 times by 4.5 is 22.5. Now again, we have centimetres as the units, so we need to write the area as square centimetres. For the second example here, area is equal to a half times by base times by height. And even if you write this formula out all the time, it gets it into your head, drills it in there so you don't forget it. So this is equal to a half multiplied by, the base here is 15. Now the triangle looks a little bit funny, but we're still dealing with just the bottom part of the triangle. Just that part there is the actual black darkened line of the triangle, so we call that the base, which is 15. And the height that we deal with here needs to be at right angles to the base all the time. That's really important, that the base and the height need to be at right angles, or must be at right angles. Perpendicular is the other word that we would use. And I'll write that other word, perpendicular. Ooh, run out of room. I'll try again. Right up the top here, perpendicular, and up here. It's got it. Okay, so back to my blue, so we can finish this off. So the height that we have in this question here is a height of 7. There. So a half multiplied by 15 multiplied by 7, whack that into your calculator, and we end up with 52.5. The units here we're dealing with are centimetres, so the area is going to be square centimetres. Okay, let's move on to the next example. This is looking at finding the area of a parallelogram. A parallelogram is like a rectangle that's been tipped over a little bit. So we have, as the key features of a parallelogram, is 2 sets of parallel sides. And you'll notice that this one we had like 2 little arrows that were indicating this. When we see the line with the 2 little arrows, that's indicating that those 2 lines are parallel to each other. And then on the top and bottom here we have two other lines which are parallel, which are represented with a single arrow. So the ones which have the single arrows are parallel to each other, the ones with the double indicating arrows are parallel to each other. And the equation that we have for the area of a parallelogram is tucked into the text up there, where A is equal to the base times the height. So just like we were dealing with triangles before, we're dealing with the full rectangle tipped over, if you like. Again, the base and the height need to be at right angles to each other. It's a key feature, just like we did with the triangle. So I'll calculate the area of this one here, area of the trapezium, or parallelogram. Trapeziums are coming up soon. Area of the parallelogram is equal to the base times by the height. Which in our instance here we have a base of 13 multiplied by a height which is at right angles to the base of 6, which that's going to be equal to 78. The units here are centimetres, so we need to deal with centimetres squared. Okay. As another example of the type of thing you could encounter, if we had a parallelogram, I might change that to black. So it shows up there. If we have a parallelogram drawn like so, top and the bottom parallel to each other, the left and the right sides are parallel to each other. And for the measurements, I'm going to say that we have a base of 10 centimetres. And along this side here, I'm going to say that this is equal to 5 centimetres. That's the actual side length there, but if we have a height like that of 4 centimetres, then the sides that we need to use for our calculation are the two which are at right angles to each other. So we have a base of 10. This length of 5 over the side is not at right angles to the base, so we have to use the 4, which is the one which is at right angles. So the area for this one would be area equals base times height, which will be 10 multiplied by 4 equals 40. And the units are centimetres, so we need to have square centimetres as our area. Okay, let's move on. And I did mention we had trapeziums coming up, and here they are. A trapezium is a quadrilateral or a four-sided figure with one pair of the parallels, sides being parallel. So if we look at each of these ones that are drawn, the first one we have the top and the bottom are parallel to each other, the other two are not parallel. Second one, it's the left and right hand side which are parallel to each other, the other two are not parallel. The third one, again, we have the top and the bottom are parallel to each other, the other two sides are not parallel. And in the middle here we have our equation. Again, this is coming back to an equation to work out what the area of a trapezium is going to be. It's equal to a half, and then we have a bracket of a plus b, which is the top and the bottom, multiplied by the height, which is at right angles to the top and the bottom. The a and the b, I was just said top and the bottom, but they're the two parallel sides. Okay, so we look for the two parallel sides, and then we need to have the distance between those two parallel sides. So for this example that we have here, area is equal to a half a plus b multiplied by h. Now the two parallel sides are the top and the bottom in this instance here. So we've got 6 on the top, so we've got a half 6 plus b on the bottom is 10, multiplied by the vertical height here, which is 4. So here we have to firstly work out what's inside the bracket. So 6 plus 10 inside the bracket is 16. So this is now equal to a half times by 16 times by 4. And a half of 16 is 8. 8 times 4 is 32. The units we're dealing with here are centimetres, so we're going to have square centimetres. Okay, and that'll give you enough to move on to the puzzle sheets and work through those, and I'll make up another one of these for the area of a circle and some combined shapes.